wrong 5 times. You got it right once by accident.
Okay, a little bit about safety. So you used to have a lot more questions, especially on the general and technician safety. Just kind of cut it down. So basically, it's talking about radiation exposure. It was hazardous materials. I think they've taken that question out, and about grounding. So if you're putting up an antenna, or especially a tower, when you're working at heights, it's obviously dangerous, especially the older you are. Like if I fall off the roof, it's probably all over.
Yeah, I hear you on that one.
Sometimes I think if I fall off the curb, so.
I mean, sometimes I sleep funny.
Well, I fallen off my flip flop and it hurts.
But besides the danger of climbing towers, falling off the roof, or falling off the tower, probably the most common thing is lightning strikes, where it doesn't have to be a direct strike; it can just be close. In fact, we're not sure, but we think there was one out at the Space Center which took out a significant amount of equipment in our ham shack. The logging computer and everything that was connected to it lost its USB Ethernet.
Wow.
And the Elecraft radio no longer has USB.
Gee.
That's expensive one to replace.
And it's too old, and they won't repair it. And apparently you can't buy a board for it. I'm not sure what they're going to do. But it also took out the Ethernet switch that things were connected to. And we're finding out that there was apparently some power switchover thing around the same time, which I'm not sure if it was lightning or power people did something bad. So as far as lightning, the main objective is to try to get the lightning current to ground as soon as possible. You definitely want to get it to ground before it gets inside your shack, house, whatever.
Point to time.
Okay.
I guess, yeah.
Go ahead.
My question, I guess, was I've seen some houses that they put these lightning protection things.
Yeah.
You'll see like a little foot high thing throughout their house.
Right. And they're very expensive, by the way.
Yeah, and I'm like, just don't know that that would be effective for anything. I mean, just it seems to me that I don't know, is that like snake oil that people are buying, or is it really?
Well, if it's done properly, it works. Properly means that at every point, like every corner and the ridge points, you've got those, like 18-inch, 2 feet, and they have to be all connected together through very heavy gauge wire and all brought down to a ground system that completely encircles the house. It's very expensive. You'll see it commercial people do it, but what it does, it kind of attracts lightning if it's set close. So instead of hitting your antenna or your house, you got these ground rods sticking up in the air. Okay, so you're going to get the difference in potential. So it's going to strike those, and those 20,000 amps supposedly go to ground.
Yeah, I always wondered, man, 2-foot thing sticking up there, is that really going to do?
Well, it doesn't matter how high it is. I mean, the higher the better. But you get, well, if you ever notice power lines, they will have a ground wire above the power lines. Usually you see that little one,
Yeah.
and that gives you a cone of protection over the power lines.
Yeah.
So it hits those, and those are usually not that heavy gauge. You know, like on every pole, they're tied back to ground.
Okay, I was just curious if that was something that has to be expensive.
Oh yeah, it's not practical for most people. It's kind of the Benjamin Franklin thing. They started that, but his didn't really work because it wasn't robust enough. Kind of like the old story about the kite and the wet string, which is a story.
Which is why you bold.
Yeah. Well, you can read Kathy Joseph's book on the lightning tamers, and she talks about that, what really went on. It was kind of a parlor trick type stuff they were doing back in those days, but they didn't know what the hell electricity was or lightning. What's the primary function of an external earth ground or ground rod? To dissipate the charge. RF exposure. The frequencies we deal with are all below ultraviolet, so they only can create heating of body tissue. They're called non-ionizing radiation, where ultraviolet and gamma rays and all those things are ionizing, and they actually can damage your DNA. So that's one of the things why radiation exposure isn't a burn per se. I mean, it actually can screw up your DNA, and if it does enough of it, you're SOL.
Cells can't replicate.
Huh?
Cells can't replicate properly.
Right. They have a thing called SAR, or specific absorption rate, okay, which is how fast or how much the body absorbs it and will generate heating depending on the frequency and the amount of power. So it's frequency dependent and also power dependent. And there is a chart, which we'll get to after this one. What does SAR measure?
Charlie.
So the FCC has set these minimum permissible exposure limits. I think it's actually based on some IEEE data that they use. And there's been a change in it because they're now including not only the E field, but the H field. So there is some, and I don't pretend to understand how much the H field affects your body, but apparently high enough magnetic fields can affect things, especially in combination with the strong E field. Because you're actually getting both here. All waves, light waves, radio waves, are all E fields and H fields. It turns out that we use the 30 to 300 megahertz, and that's where your body is most susceptible. It's actually, I think, around 50 or so, but in that 30 to 300 is the worst case as far as exposure, where you get the most heating. And it's essentially soft tissue, your brain, your eyeballs. Yeah, I mean, you know, enough of it, turn your eyeballs white.
Oh, jeez.
So here's the famous chart. and you notice there's a solid line and a dashed line. The solid line is what we call controlled exposure. So that's where, you and your shack, okay, because you know what you're transmitting, where the antenna is pointed, and all that kind of stuff, and you've done your calculations or measurements. Whereas the dash line is called uncontrolled. That's your neighbor, because you may have your beam pointed at his house. He doesn't know he's being radiated. Okay, so the limit for your neighbor is 0.2 milliwatts per square meter or square centimeter. And the limit for controlled is 1 milliwatt in that 30 to 300 range. Now, this also has this other line in here, which is the new H field stuff. Fortunately, there's no question about it. And you can see that the lower frequencies below 30 really are allowed much higher power densities. When you get up into the VHF and UHF, it's better, but not as good as the lower frequencies. Over what range of frequencies are the FCC human body RF exposure limits most restrictive? Let's see. So basically it says you're required to do a evaluation, exposure evaluation, anytime that you've made a change. You put up a different antenna, you get a different transceiver, anything that would affect your radiation pattern. You add a linear amplifier, anything like that. And there's several ways to do it. There's some calculators. There's one on the E0A site, or you can go buy an expensive calibrated field strength meter and go around and measure stuff. But not many people do that.
So when you do those calculations, is it really like posted,
You're supposed to have it available in your station along with your license.
if you're doing mobile stuff, I'm sure it's still required. They understand.
Yeah,
Like,
technically you'd have to have it in your car, which I don't. Actually, I think I haven't done it since I put the radio in the car. I did it when the radio was in a shack with different antenna, so definitely need to do it again. And the only exception is for handheld transceivers before May 3rd, 2021. I'm not sure what's significant about that, but something changed. I guess they couldn't, when they decided to do these, they couldn't go back. So when must an RF exposure evaluation be performed on an amateur station operating on 80 meters? Yeah, the 80 is just a red herring. Which of the following types of equipment are exempt from RF exposure evaluations?
Sure. That makes me wonder if it's like stupid. It makes people know.
Okay. When you get up into the microwave stuff, okay, because of the higher power density, because as the wavelength and the frequency gets higher and the wavelengths get shorter, you can have more gain on an antenna just because of the physical size. So you can get a much higher power density up in the microwave regions. You have to be a lot more careful on what those limits are. What hazard is created by operating at microwave frequencies? Okay. It says that the body reacts to both the E and the H fields, but I don't know any more about that on how it reacts with an H field. I guess reflections from the ground or scattering from something nearby, the E0A or whatever, can make things vary depending on where you're at. And that the E field and the H field can have peaks at different locations. As you move around, the E field and the H fields can change. And I think this is basically confined to near field as opposed to far field. But this is some new stuff, and I have to admit I don't know a whole lot about it, except there's a question. So why? Huh?
It's all of these.
Yes, it is. They made it easy. You have to take into account the uncontrolled limits. So when you do the calculations, you have to actually do both. And if it tells you that you're exceeding the 0.2 milliwatts at 20 feet from your antenna, you need to make sure that your antenna is more than 20 feet away from your neighbor. When evaluating RF exposure levels from your station at a neighbor's home, what must you do? There's a key word in there.
Yeah, I'm just looking at there's maximum permitted exposure and maximum permitted emission. So that's like their first discriminator.
That's right. So it could be exposure.
Remember, there's uncontrolled.
So your neighbor is what?
Uncontrolled.
Uncontrolled. And we're talking about exposure.
But what if you don't like that?
You still have to document.
The amount of radiation.
So the coroner can. Let's. Oh, in cases where you've got multiple transmitters, something like a broadcast port over in Cocoa, where there's a tower, there's lots of different transmitter antennas on it, commercial and at least one amateur. I think there's maybe more than one. You have to take into account when you do the exposure calculations, every transmitter that is more than 5% of the total. If you're under 5%, then you're not responsible for doing it because you're so far below everybody else. So when evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations. Sure. Okay, towers and antennas. The first thing is the concept of 100% tile, which means you should have a lanyard connected between you and the tower, some part of it, specifically a leg, at all times. Now, they also prefer that you have the connection above your head I think that means when you fall, okay, you're sort of hanging from it, you know, head up, feet down. Whereas you had it down like on your waist or lower, you wind up upside.
It'd be like bungee,
Yeah.
minimize fall distance.
And by leg, most towers are either triangular or square. I'd say most of them triangular, so they got 3 legs, and then cross pieces of. So you connect to a leg.
Back in the early '70s when I was, child, a friend of mine's house, radio station. Tower out back, it was big, right? But back then they didn't say shoot the line. Like, ain't true. I'll never forget slide hand rise. I looked down.
Yeah, never look down.
I mean, you know, it's just that or playing lawn darts. What's the least hazardous thing done?
You just throw them up in the air.
My brother had this.
I had one of them with brick.
Okay.
Yeah, a couple of us learned a lot about how to make it a catapult. Just a pile of rocks and a board, and put this. It's like half brick on one end. I jumped on the other end. It was none. See, because it was just down in the hollow. You couldn't see it. Bam! This went straight up, hit me in the head. Blood, shirt was full of blood. My mother about had hysterics. And then I went to the hospital, and this old Japanese doctor brought out this. They had me laying there. Looks like a hypodermic needle. It was probably 2 inches in diameter and had a point on it as big as my finger. And I looked at it, and it was actually water washed. I thought it okay. What's meant by 100% tie off?
Bravo.
So what should lanyards be attached while climbing?
Delta.
Where should a shock absorbing lanyard be attached to a tower when working above ground?
Alpha.
Okay. And I just left this one in there because they took the question out. But you used to have to know about beryllium oxide, which they use a lot as an insulator in electronic equipment. And then the dichlorinated biphenyls, some of the high voltage capacitors, transformers, the commercial power transformers, they use that nasty stuff.
All right, so it said beryllium oxide, don't eat it.
Right. Most things are okay as long as you don't eat them.
Yeah.
Very good point.
That's like that stuff, quick pool, that acid that you use. I asked the guy that, this is the stuff that